Hey everyone, I'm glad to see you and I need your help. Can you please join me on this website? I'll do the same. So you can actually pull your phones and it will be okay. This is a little experiment of mine that I'm conducting on many conferences. Hopefully, yes, maybe. Yes, here we go. Thank you for joining so many devices. This little experiment actually shows a couple of things that I really love about the internet. First thing is that you were not afraid to enter this website because you knew that I won't steal your private information, that it won't take a lot of your disk space, crash your OS, or take multiple steps to install and run. It just worked. Plus, it just magically worked on 48 devices across 8 different vendors, 6 OSs, and 15 screen sizes, which is pretty amazing to me. But web is also pretty powerful. 100% of the devices that here allow for a geolocation, with your, of course, permission. 100% again allows for WebGL, so we can bring very performant and beautiful 3D to the web. And 80% allows access to camera and mic, again, with your permission. So this mixture of powerful features, of safety, of ease of access, and portability is what allowed web to absolutely conquer the desktop. And even apps that are running outside the browser window nowadays are still using web technologies like Slack, like Steam, like iTunes. On the mobile, however, we have some challenges. And we have to fill a couple of gaps to make sure that web has a great future on the web, on the mobile. And today I will talk about 3 things. I will talk about offline capabilities, about push messages, and ability to install. Quite amazingly, all these 3 features are based on a technology called Serviceworker, which already 75% of the devices here support. So let's talk about web and building web apps in 2017. My name is Konrad Dzwinel, and I'm a front-end engineer at Brainly. Brainly is a Q&A platform for kids where they help each other to understand school material and finish homework. We are very similar to Stack Overflow in many ways. We, for example, also implement gamification system. Besides that, I'm a Google developer expert for web technologies. I have a couple of my own open source projects, but I also contribute to Chromium, the project behind Chrome. And the Chrome team is the team that led the efforts to bring offline capabilities to the web. And they did it using something called Serviceworker. So Serviceworker is basically a programmable proxy. It's a script that sits in between your page or your web app and the network. It gets informed about all the requests that are being made by your page and gets all the responses. And the thing is, Serviceworker can modify both requests and responses. So let's see some practical example. Let's assume that you have a blog, and you want articles on that blog to be available offline to the users that previously visited these articles. So your page, whenever it makes a request for an article, it goes to Serviceworker, and Serviceworker, based on, for example, URL, can figure out that this is a request for an article. In this case, it can implement some caching scenario, some specific behavior. It first goes to the cache and to see if your article is already there. And this cache is not the cache that browsers normally use. This is your cache. You can put anything you want there. You can remove stuff from there and look for stuff in there. But let's assume that this article haven't been yet visited and it's not there. So we normally, like normal, we go to the network and fetch it from the network. We return it back to the page so it can be displayed, but we also put it in the cache. So the next time user comes, even if he's offline, he will still see the article. I'll show you a bit of a code. This is just to show you how it works more or less. I know that most of us here are programmers, so seeing a bit of code makes it more real. So on your page or on your web app, to start using Serviceworker, you have to first register it. And this is done by this single line of code, where we specify URL of a script that will be our Serviceworker. There is actually even simpler, more declarative way of doing that that's being currently tested in Chrome. So now we are in the worker.js script. And this is a script that doesn't have access to DOM. It's absolutely separate, and I'll explain why in a sec. And what you can do there, you can listen for specific events. And one of these events is fetch. Fetch allows you to, fetch is called whenever any resource is being requested by your page. So in our, going back to our example, if we are getting a request, we can check if it's an article based, for example, on the URL. And then we tell the browser that, OK, we'll handle this request ourselves. So don't do your usual thing. We'll do our thing. And what we do is we go to our cache and look for this request. If we find something, if we find the cached response, we can just return it. But if we don't find it, we can fetch it from the network. And on its way back, we both return it to the user and put it in cache. But this was a very simple scenario, very similar to what browsers normally do. So let's see something a bit more complicated. So let's say you have avatars on your blog, avatars for users that are commenting on your articles. And what we can do is, whenever your page requests an avatar, we can check if it's in cache. But if it's not, we go to the network, same as in previous scenario. But again, OK, sorry. Oh, the clicker is, yeah, OK. So we go back to the cache. If it's not found in the network, because, for example, user is offline, we go back to the cache and grab the previously cached, just generic avatar, like gray image default thing. And we return it back to the page. And page can actually display it, and everything will look all right. It means that there will be no broken images, even though user is offline. The other scenario is revalidating caches. So let's say you have a little widget on your blog that shows how many users are actively looking right now at your page. And it's not super important for you to show accurate number. You want to show this widget as soon as possible, so there is no loader, for example, before it shows up. So whenever this widget is requested, we can grab it from cache, return it back to the page. It won't be the freshest version, but then in the background, we can go to the network and update the caches. So the next time user requests this widget, he will get the fresh version. Serviceworker also solves one extremely frustrating problem on the web. We've probably all been there. You have some form, you fill it up, it takes quite a lot of time, and then you click Save. And the little loader appears and starts spinning. But nothing happens. It doesn't go away. And it's both frustrating on desktop and mobile. But on desktop, at least, we can change the tab and do something else. But on mobile, we are basically stuck. So the way Serviceworker solves this is by introducing background sync events. Instead of normally sending data to the network when the user clicks Submit, what you can do is request a sync event. The sync event will be fired. The sync event will be fired whenever user has connectivity. So if user is already connected, it will fire right away. But if user is offline, it will fire later on. And when it will fire, it will wake up Serviceworker. And that's why it's important that Serviceworker is a separate thing from the page, because Serviceworker can be woken up without your page running. It can be woken up without the browser running. It all will happen in the background. So Serviceworker will be woken up, and you can do all the hard work of communicating with the network and sending the data that user requested you to send. And if this fails for some reason, let's say sync event fired, but the network wasn't really there, browser will automatically schedule another sync event for you. So you don't really have to care about this. And there are like tons of different things that you can do with Serviceworker. These were just a couple of examples. What I like is you can check the connectivity that user has right now. For example, if it's 3G or 2G, and based on this, fetch different image, for example. Get better quality for speedy network, and get some smaller images for 2G. But there are tons of different things. So let's see it in action. Flipkart.com is an e-commerce website in India. It's one of the biggest, if not the biggest. And you can just browse stuff here. So let's see some phone. Let it load. OK. And now if we go back to the main page, go offline, they changed their layout to gray. Everything is gray. But this is something they decided to do. This is not what the browser is doing. It's to indicate that user is offline. And the website still works. And the search and the actual device that we looked on before still is available for the user. If we reload the page, again, it will still work. And what I like what they did here is, like, normally when you're online, you have this buy now button. And they are replacing it with colas and provide this item number to actually buy when you are offline. So this is a nifty trick. Another thing that I told you we'll talk about is our push messages. And push messages is something that you can subscribe for after your Serviceworker is registered. So again, the same line that we had before, we register Serviceworker, and then we can subscribe for push messages. That's it. User has to, of course, allow this, but if he does, we get an endpoint that we send back to our backend, which can use it for sending push notifications to that specific user. So how it works. Push message comes. It wakes up Serviceworker, again, like with the sync event. So again, your browser doesn't have to be running. Your website doesn't have to be running. Serviceworker goes and fetches some stuff from the network. So like for example, if you got a new email, you can fetch it from the network, put it in the cache, and only then show the notification. So that next time, so that even if user is offline and he clicks on notification, he will be presented with actual data. In Serviceworker, inside a worker script, it looks super simple. Before, we have listened for a fetch event. Here, we are listening for a push event. And here, I'm simplifying things a bit. I'm showing a notification right away. So this is in action. It's a simple chat app, web chat app. And even though I killed it off, I will still get a notification. Pretty obvious. OK, so let's talk about installability. This feature has been in the browsers for a while now. Unfortunately, it's been pretty much hidden in the browser menu. It's here on the Add to Home Screen functionality. Thankfully, nowadays, when you have Serviceworker installed and you have something called Web App Manifest that we'll cover in a second, user will be prompted to add your web app to the home screen. So this is much more findable. So let's go to Pokédex. This is index of all Pokemon. And since I've been on this website before, I get prompted to add it to the home screen, which I did. And now it looks like a just normal app, has a splash screen, and opens up in a full window, like without the browser UI. So web app manifest. This is super simple metadata that you need to put in order for browser to know how to run your app when it's in a standalone mode. So we have name, we have short name that is being used under the icon when you add your app to the home screen. We have some icons. We have display property, which is actually interesting because it can have a couple of different options. So standalone is what you have seen, like no browser UI at all. But you sometimes may want to have some browser UI, like minimal one, just showing the URL without ability to edit it. So this is called minimal UI. You have also full screen mode, which will just open full screen, like it's something that is perfect for games. And finally, we have browser mode, which will open full browser UI. We have orientation, which locks orientation. We have start URL, which tells the browser what is the starting point of your application. We have background color that is being used on the splash screen, and theme color that is being used on the bar when you are browsing open applications. So you may be wondering if this technology is actually ready for production. And it has been shipped with Chrome, Firefox, and Opera some time ago. Safari has it on its to-do list, and Edge is actively developing it. All the companies behind these browsers and more took active part in shaping the API. So going back to my question, is this technology ready for production? Yes, because all the users of the browsers that support can take advantage of it right now. For other browsers, they will just get normal experience without offline, without push messages, but still normal working thing. And since I have some time, I just wanted to add one more thought. The features that I just quickly covered are a little something that is happening on the web. There are so many things, so many other things that I haven't time to play with, like WebVR, which is virtual reality. It's being developed by Firefox and Samsung. Intel is doing cleanup in the sensor APIs to make them look all the same and to add new ones like ambient light and barometer, for example. Chrome just started shipping Bluetooth, Web Bluetooth API and Web USB. There are web payments. There is WebGL2 coming. So many different things, all done in open, all done by a community of companies, of individuals. You can see all the drafts for these APIs, take active part in shaping them. And that's probably what I love the most about the internet. Thank you so much.